All right, so I'm doing this recording because there was an issue with the recording online, and I apologize for that. But here we're going to go a little bit faster, and because we won't have to wait for the class on campus. And I'll explain a few things about Microsoft Excel, and then a few things about MATLAB. So we're going to do some formatting, some addressing, and some statistics in Excel. Then we're going to jump over to MATLAB. We're going to do some statistics in MATLAB. I'm just going to go ahead and recreate the entire lecture because I don't know when it cut off. So let's just go ahead and get started. So this is Microsoft Excel. I'm sorry. I've told you several times this semester that this isn't my favorite program because a lot of people use it to do engineering calculations and they misreference cells and it sort of screws everything up. The reason for that is that this program, whenever we create something, and we're going to create something today, and I'm going to show you how to do it, but when we misreference things, it creates problems for other people. I guess that'll be best shown through an example. So let me come up to cell A1, and I'm going to go ahead and type formatting. Okay, and while I do that, I want to show you a few things about how to format in Excel. Excel is a spreadsheet program. I'm sure a lot of you have bumped into it before at this point, but it enables us to arrange all of our data. Now, what types of data we can arrange are, if you come up right here to the number pane, you click this drop down, this is all the type of data that we can deal with, or types of data. We can have general, where Excel just sort of tries to figure it out, number, currency, and accounting, which are both dollars, and I don't really know what the difference is between the two because I'm not a super Excel genius or whatever. There's dates, times, percentage fractions, scientific notations, and then just simple text. But usually people stick with, or in engineering, we usually stick with general and number, and maybe some dollar amounts and some dates. That's usually where we stop. But you'll see here when I typed in formatting, the length of the word formatting actually exceeds the width of my cell. So what I can do is I can hover my mouse over the top, and you'll see that I have a downward facing arrow. But if my mouse goes a little bit farther to the right and I hover over the line between columns A and B, I can actually click, hold, and drag out. So now I can change the width, and that's good because now we can take a look at a few other things. We're going to build towards an example that we're going to hinge off of for the better part of our Excel conversation, and that is that we're going to have some samples, okay? And following the formatting that we had for rules of proper plots, we're going to go with whatever this phenomena is, sample, whatever the variable is that we would use to denote it in text or some equation, and then whatever the unit is. We're going to say that we're measuring mass. Let's just pretend that we're in some sort of physics laboratory or chemistry laboratory. And then we're going to compute the weight. Okay, weight being W, and that being in newtons. All right, again, so now I have 1, 2, 3 columns. I was sort of formatting as I went, but there's also another way that I can fit the width or change the width of all of these columns. And that is I can just hover my mouse over the right-hand edge of the column I'd like to change the width of, and I double click. And you'll see that now my C column is wide enough to accommodate my weight, open parentheses, W, close parentheses, and then my newtons. I can also do that here. So let's go ahead and make column A just really big. And then we'll just double click. There we go. So we have some samples. Let's say 1, 2, and 3. All right, let's say we actually have 10 samples. So what I'm going to do is I've created a pattern, 1, 2, 3. I don't want to say 4, 5, 6, 7, 8, all the way down to whatever I have. So my pattern, which consists of 3 cells that all have some sort of step increment or something in common, I just hover my mouse over the bottom right-hand corner, click, hold, and drag down. So let's give ourselves 10 samples. Now that is something that we need to hit on a little bit more over here. So let's call this some extra formatting. Oh, that's not how we spell extra. And I do apologize for the click-clack on my keyboard. If you can hear it, it's a mechanical keyboard that I use at home. And it's really all I have right now. So let's talk about numbers. Let's talk about evens. Let's talk about odds. Let's talk about days. Let's talk about months. Let's talk about decades. Okay, that'll give us a few examples. So numbers, we had what we had before, 1, 2, and 3. We have even numbers, 2, 4, and 6. We have odd numbers, 1, 3, and 5. Again, we have to start with 3, okay? Our pattern has to consist of 3 values for Excel to try to figure out what it is that we were meaning. And then so I have January, I have February, and I have March. And so I put March in the wrong cell. So what I can do is I can click on the cell, and then you'll notice that my cursor is a white cross. If I hover my mouse over the bottom, it changes. Once it changes to this cross with 4 arrows on it, I can click, hold, and drag, and I can drag this wherever I would like in the spreadsheet. So I like it to be down here underneath January and February, and then we can do decades. Let's say 1950, 1960, and 1970. All right, now I have a little bit of a problem here. First, this extra formatting, it applies, is the right word to use, to columns J through O. So now what I can do is I don't really want to make my column J excessively wide because numbers is then, the word numbers doesn't really fit in this cell very well. And then I have 1, 2, and 3, and those are all pretty small. So let's do this. Let's take cell J2, so it's in column J, row 2, okay? And I'm going to click, hold, and drag over, and I'm going to highlight, or I can just click on the cell that contains the word extra formatting, and in that row, come over to column O, and just press Shift-click. So click on the first, hold Shift, click on the last, and now I have all of the cells highlighted that are above all of my extra formatting. Then up here in the Alignment tab, okay, I can come and say Merge Center. And now, what was only in J2 is now in J2, K2, L2, M2, N2, and O2. They're all one cell. So now I have extra formatting, and now I can double-click on my right-hand edge of my J column, and this auto-fits the width. But I also have another problem. These are all, everything that I've typed up to this point is sort of jammed up against the left edge if it's a word, the right edge if it's a number, which is not what I want. I'm going to highlight all of these. Just click, hold, and highlight everything. And then I'm going to come back up to my Alignment tab, and I'm going to center horizontally and center vertically. I actually did those in reverse order. That's horizontally, that's vertically. My days are actually exceeding the width, so I'm going to come up to the right-hand edge of my M column, double-click, there we go. But now what I want to show you is this. I'm going to highlight all of these, not the headers, okay, just the data. So the 3 lines are the 3 elements of data in each one of these columns. Then we just click, hold, and drag down. And what you'll see is that now I have some months that have exceeded the width. My days aren't really doing that because Wednesday is the widest. So let's go ahead and double click on the right hand edge of N. And now I have my numbers, my even numbers, odd numbers. I have my days of the week, months of the year, and I have some decades. And what I can do is I can also change a few of these things. So let's first make this so we have these sort of little gray lines that show us the boundaries of all of our cells. But if we were actually come up to File and Print, and I looked at a preview of all of this, which is right here, you'll see that the cells don't appear. Okay, so this is page 1, and this is page 2. So I don't see the edges of the cells, or at least those squares that we see. So let's go back. So now what I want to do is this. I want to come up, so I've highlighted this table, right? So this is our little table inside of our spreadsheet program. And over here in the Font tab, I want to click and I want to say All Borders. All right, so then when I come up to File and Print, and I take a look at my preview, there's page 1 without the borders. Here's page 2 with the borders. So now we've created a table. So this is something that we could create in Excel, copy and paste into Microsoft Word, or we can actually directly link it, which is not something we're going to cover in this class. But so now I have all of this delineated, right? But let's say these numbers weren't numbers. Let's say they were currency, all right? Or dollars. Let's put it that way. Now what I can do is this. I can highlight all of those numbers, 1 through 18, which were counting integers, and then I come up to the top. I click on this drop down, and what was a general, I can come down to currency. And now they all appear as currency. So that's good. I can take the odds, and I can turn them into time, right? And I can take 1, 3, 5, all the way up to 35, and I can turn them into some times. Now, this doesn't really make any sense, and that's a point that I want to make. The pattern that you give Microsoft Excel has to make sense. So it can't take all of this data and turn them into times, because if we were to follow some sort of military time or some sort of universal time code, we could have hours 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and 21, as well as 23. But we don't have hour 25 or 27, 29. We don't have anything bigger than 24. So we'd actually come over here. We can say hours, all right? We can say 0, 1, 2, 3. And I can highlight those 3. I can turn them into time. And now I get, well, I don't understand what that is, but okay. Let's say, oh, I'm sorry. It needs to look like this. That's why. So you do have to have the colon for it to figure everything out. So we highlight those. Forgot about that. We bring it down, and we can turn that into time. And now we have midnight, 1 a.m., 2 a.m., 3 a.m. So we had to use the colon, so that was my fault. But it does automatically switch over. Well, we want to include that in our table as well. So I'm going to take my extra formatting. Now I'm going to highlight the one cell that contained extra formatting, which is made up of these 6 cells, and the extra cell that I want to add. I'll click Merge Center, it'll unmerge, then Merge Center, it'll remerge. Then I can highlight the whole thing, click on my all borders, and now I have my table back that shows me a little bit of extra formatting. Well, let's come over here. Okay, we center formatted all of this, but let's go ahead and add some borders to it. So I have samples, masses, and weights. Let's make up a few random masses. We'll just throw some random numbers in here. Nothing close to reality, just creating a few things. And let's just go with 1. Okay, so now I have some samples and I have some masses. So the next thing we're going to talk about is formatting and relative addressing. Okay, now this, like my extra formatting, now applies to everything here. So let's actually move this down. We'll highlight these 3 cells, A2, B2, C2. We'll come up to merge and center. We also want to make that a little bit bigger, so let's just bold it and bump it up. We'll make extra formatting bigger, so we'll bold it and bump it up. Okay, so I've just increased the font size and made it bold. We included that inside of the table, so let's go ahead and include this inside of this table. And I don't really like that that's, well, we'll just leave it. We'll see how it goes. So now what we're going to do is we're going to type a few equations. So if I'd like to compute the weight of a mass given the weight of an object given its mass, and I'm doing so with grams going to newtons, then I know that force equals mass times acceleration, that weight is a force, so I'm going to multiply this mass times an acceleration, and when it's weight, it's gravity that's the acceleration. Well, now I'm going to type an equation, so I'm going to do so by first typing an equals sign. I need to have my mass, so I'm going to click on the cell to the left that contains the mass of sample 1. I'm going to multiply by 9.81 because that's the acceleration in meters per second squared for gravity in the SI system, which is what we're working in because we're going from grams to newtons. Now, a newton, by definition, is a kilogram meter per second squared. So these are in grams. I would need them to be in kilograms, which means that I now have to divide by 1,000 because 1 gram is 1,000th of a kilogram. And I press enter. So now I have the mass in grams and the weight in newtons of that mass. Well, let's stop right here for just a second and talk. So we're working out of cell C4. That's actually going to be called an equation cell. An equation cell is something that utilizes functions in Excel. It utilizes just numbers that we give it, or it utilizes other pieces of information that we target in other cells. So that makes cell B4, what's called a target cell. So I have an equation cell and I have a target cell. When we use relative addressing, the target cells are going to move relative to where we copy and paste our equation cell. What does that mean? It means this. So I'm going to press escape. Now I see the number, which is the outcome of the computation in my equation cell. You'll notice that, again, there's this little black box in the bottom right-hand edge. That's really going to be my automatic copy and paste for me. My cursor is a white cross. I'm going to hover over it till I get a black cross, click, hold, and drag down. And now I have the outputs of the computations or the weight in newtons for all of these masses. But here's the deal. My first equation cell, I pointed to or targeted a cell that was 1 to the left. So I'm going to pick another one at random. Let's sample 5. Sample 5, the equation cell is C8, or it's in cell C8. The target cell is in cell B8. So what it means for this target to be relative, we're addressing this target cell relatively, is that no matter where I copy and paste this target, it's always pointing, let me make that a little bit wider, it's always pointing to one cell to the left. So that target moves relative to where we paste our equation. Now, that's particularly useful if we have a table like the one we have here, but it's not as useful if we move on to other types of addressing. For instance, so I have an example here. This was formatting and relative addressing. Let's move down and let's call this fixed addressing. Okay, so this is our introduction to fixed addressing. Again, I'm going to highlight these 3 cells. I'm going to merge them. We'll bump them up a little bit. We'll bold them. And I'm actually going to copy my entire example here and just paste it right down below. So again, just highlight, right-click, copy, come down, right-click, paste. Now for fixed addressing, I'm actually going to highlight all of these cells because I want to rework this equation that is now being used to compute the weights. Highlight, and we're going to say clear contents. So now there's nothing in any of these cells. I know because when I click on them, there's just nothing up here in the equation bar. There's nothing I can see right here. And now I want to work on something different. Over here, I'm going to say gravity at testing location. Okay, so now I have 1, 2, 3. My text seems to spill over into 3 cells. I don't really have a particular problem with doing this, just for this label, but I do have that problem for other reasons. So I'm going to highlight these 3. I'm going to merge and center. Okay, over here, I'm going to type G space equals space, then I'm going to get out of that cell. And then I'm going to move over 1 cell, leave it blank, move over 1 cell, and I'm going to say meters per second squared. Now, the reason for this is when I target information from an equation cell, I can only have numbers. I can't have descriptive information. So I couldn't have G equals 9.81 meters per second squared and then target a cell that contains all that information and use that in a calculation. As a matter of fact, let me just show you that. So I would say G equals 9.81 meters per second squared. Okay, I'm going to combine all of that into 1 cell just to make this point. For a little bit of formatting, I'm going to come over to my G equals, and over here in my alignment, I have left, center, and right alignment. I'm going to right align that cell. In this cell where I'm going to put my number, I'm going to center align it, and then I'm just going to put 9.81. So now I have 3 pieces of information in 3 different locations. I'm going to double click on this cell to make it a little bit smaller. So I have G equals 9.81 and meters per second squared. In this cell, I have all of that in 1 cell. So here, to compute the weight of mass 1, I would again type equals. I would select the mass. I would multiply by. I would select the gravitational constant that I want to use. Over here, it's 9.81. And I would divide by 1,000. I press enter. I get the exact same number as up here when sample 1. So that all worked. Now, I want to make 2 points here, and the first point is this. If, and I'm going to double click this cell, instead of using F19, I'm going to again hover my mouse over the bottom edge. I drag that down, or I could just cancel out, delete the whole thing, and say equals, click on my mass in my target cell, times, click on my gravity down here, divided by 1,000, and I get hashtag value, or number sign value. And the reason for that is this. This doesn't contain any discernible quantitative information that I can use in a calculation. So I'm going to delete it. I'm going to say equals, again, my mass in my target cell, times my gravitational constant divided by 1,000, because I'm going from grams to kilograms. Now, I'm going to delete this cell. So right-click, delete, because I've made my point. Let's just clear contents. I apologize. And then we're going to unmerge it. There we go. So now it's 3 cells again. Because the next thing I want to do is this. So in order to compute the weights of all of the other samples, in our previous example, we just hovered our mouse over the bottom right-hand corner, click, held, and drag down. Now I have a whole lot of zeros. Here's why. Let's pick one at random. We'll do sample 5 since that's what we did before. I double-click. My first target cell is 1 to the left. My second target cell is now pointing off into the oblivion, or into the abyss. That's because right here in my cell C18, if I double click on that, my first target cell is 1 to the left, 0 up and down. My second target cell is 1, 2, 3 to the right, and 1 down. If I look at my equation in 5 again, I'm just going to double click. My first target cell is 1 to the left, 0 up or down. My second is 1, 2, 3 to the right, and 1 down. So this is now using relative addressing. And so these 2 targets, or the location of the targets that are being used for this equation, move relative to where it was pasted. Well, that's not what I want. What I want is this. I want to relatively target the mass, which will be 1 to the left of wherever this equation is pasted. I want to absolutely target my, my gravitational constant. To do that, I place a $sign before my column indicator for that cell, and a $sign before my row indicator for that cell. So now I'm going to press enter and make this a little bit wider so that when I double click, it's all right here. Now I have my mass relatively targeted, which means no matter where I paste this equation, I'm going to be pointing 1 to the left to find a mass. And I'm going to multiply by my gravitational constant, which is always, always, always now fixed to be aiming at or targeting cell F19. Which means that when I again select this cell, hover my mouse over the bottom right-hand corner, click, hold, and drag down, I now get the same numbers that I have in my first example, and it's always targeting cell F19. Now, why is that important? That's important for one reason. We have experiments that we run all the time. And certain characteristics of the testing protocol, whatever, okay? And to that end, it's sufficient to say that this semester we've already talked about assumptions. And one of our assumptions is that gravity, when working in the SI system, is 9.81 meters per second squared. And we've talked about how that's not always true, because that is true under normal atmospheric conditions at sea level, some nominal temperature, nominal barometric pressure, 1 atmosphere, so on and so forth. But that's not always the case. Currently, I'm in Lubbock, Texas, which means I'm about a mile above sea level, maybe a little less. So my gravitational constant is not 9.81, it's probably 9.806. And while that may seem like it doesn't really matter, when we have very small masses in grams, they give us very small weights in newtons, that 1/5 of a percent or 1/2 of a percent or whatever, it may be pretty important. So I'm going to press enter, and all of my weights right here change based on whatever my number is. Let's say I'm really high. Let's say my gravitational constant is 9.79. Now I have all of my numbers that automatically recalculate based on whatever gravitational constant I change in this square. I'm sorry, cell. Well, that's pretty important. So one of the next things we can do is, let's double check something. All right, good. Our audio is doing fine. So now let's talk about a third type of addressing. And for that, I actually want to go over to a new sheet. So this, down here at the bottom, we have sheets inside of our Excel spreadsheet. So I'm going to say I want a new sheet by clicking on the little plus button. This is going to be called mixed addressing. Okay. Now let's move that out here because it's a little bit farther away from the edges. And for mixed addressing, let's say that we have some sort of product that we're going to sell. We've talked in our statistics conversation about bolts, so let's go ahead and say bolts. So up here, we're going to say the number of bolts sold. So we're going to be a supplier for bolts. We're manufacturing them. We've already talked about how to check to see if taking a sample in our manufacturing batch is good. Over here, we're going to have the price per bolt. Okay. My prices per bolt, let's go ahead and do, I don't know, let's say 0.07, 0.08, 0.09. I guess this spreadsheet that we're using could be used, let's go all the way up to 25 cents. There we go. These are going to be dollars. So again, with all of that highlighted, I'm going to come up to my data type, and I'm going to change it to currency. My price per bolt sort of disappeared here, but not only that, it applies to all of these values. So we're actually going to do something unique here with formatting this. I'm going to highlight all of the cells that are to the left of my, my dollar amounts. I'm then going to merge and center them again. Now, while that's turned all of those cells into one cell, which is sort of what I want, I can also align horizontally. I can align the middle horizontal and vertical, and my price per bolt is right there. I could do a lot of different things, which we'll talk about in a minute. But the next thing I'm going to do is you come over to the alignment where you see A, B, and an arrow sort of pointing at a 45-degree angle. What we could do is, that's our orientation. We click, hold, and drag, and we're going to say rotate text up. And now I have this descriptor of all of this information aligned and oriented so that it makes a little more sense. Now, this mixed addressing thing, let's go ahead and just merge and center it over 3. That way we can double click our price per bolt and it does a little bit more, or it does a little better for us. Let's go ahead and, well, let's figure out the number of bolts sold. So if we're a supplier, right, we're not going to be selling like trivial amounts of bolts. So let's say 100, 1,000, nah, let's say 200, 300. Let's just do that so we can highlight the 3, drag it over. We'll get up to 1,500. How about that? We'll sell 1,500 bolts. So these are my number of bolts sold. So above all of my quantitated, or yeah, my calculated or stated values of bolts sold, I'm going to highlight all of the cells. I'm going to merge and center. Okay, so now I have my number of bolts sold. I have my amount or profit per bolt, not profit, but what I sell per bolt, my revenue per bolt. And I can now highlight everything, okay? And I can center it horizontally and center it vertically. And so now I have everything lined out. I'm not going to auto fit the width of all of these columns because we're going to be computing values in here, and that's going to be, well, how wide the cell is going to be a function of the output in the calculation. So I'm going to come down. So if I want to calculate how much I am going to make on selling 100 bolts at 7 cents per bolt, I'm going to type equals, I'm going to say the number of bolts times my revenue per bolt. So now I have D6 times C7. I can press enter. Great, I make $7. The problem I run into is if I click, hold, and drag this across, I run into trouble pretty fast because my target or my targets in my equation cell are relative. So I'm targeting one above, and then my second target is one to the left, which gets me into my revenue stream. Okay, I'm now targeting previous revenues instead of the amount sold. I'm going to press Control Z. I also can't drag down for the same reason. Okay, so I double click this one, I'm after this times this, and this times this, and this times this. So I'm going to press Control Z. Okay, so now what we have to do is we have to take a look at this equation. So with relative addressing, we were moving our targets relative to where we pasted our equation. With fixed addressing, we were always pointing to one cell that was always going to contain the piece of information that we needed. This one is a bit different. This is mixed addressing. So with fixed addressing, we placed a $ before the column and before the row. With mixed addressing, we place a $ before the column or before the row. And so what we need to start looking at here is when we create this equation, I have the number of bolts sold and the price per bolt. Well, the number of bolts sold is always going to be referenced, the target values for the number of bolts sold are always going to have one thing in common, and that's this. If I want to find the number of bolts sold, I can come to cell D6 or E6 or F6 or G6 or H6 all the way through R6, which means they're always in the 6th row. So before the 6th, I can place a $. Similarly, I'm going to multiply the number of bolts sold by the price per bolt. To find the prices per bolt, I can go to C7, C8, C9, all the way through C25. So we're always going to be in the C column. Therefore, I can fix pointing to the C column. Now I press enter. And now what I can do is copy, highlight my entire field, right-click, and paste. And what I have here is, now let's take a look. We have to take a calculation that we can verify. So let's say 1,000 bolts, right? 1,000 bolts at 20 cents per bolt. So 1,000 bolts times 20 cents per bolt should be $200. So we see that we already have the correct calculation. I'm going to make this a little bit wider so we can play with it. And now we see that when I have the number of bolts sold, I am pointing to the correct cell, 1,000 bolts. When I have the price per bolt in this table, I am pointing to the right cell because it's 20 cents per bolt. So that method of what's called mixed addressing is sort of a little bit of an art form. Okay, you have to take a look at your calculation. You have to take a look at, I'm targeting a property, or I'm sorry, targeting a value. I'm targeting a second value. Now they're not properties, they're phenomena, right? So I'm targeting the number of bolts sold, that's my first phenomena, and the price per bolt, that's my second phenomena. And you want to find out, what do all of the values for one of the phenomena have in common? And then what do all of the values for the second phenomena have in common? Well, let's do a little bit more. Let's go ahead and merge these 4 cells just for fun. Let's highlight the whole table. Let's give it a little bit of a I'm sorry, not a little bit. Let's give it some borders. And now since we have a whole lot of values, right, let's go ahead and take our headers and we'll bold them. We'll take our row indicators, we'll bold them. And then what I want to do is this. It gets pretty hard to find your way out into this field, you know. So we're going to give the reader a little bit of information or a little bit of extra formatting to help follow. So this is mixed addressing, and more formatting. All right. So now let's sort of, here we go. Let's highlight all these, merge, bold and bump it up, right? So that was our header for all of our examples. So here's what I want to do. I want to make it easier for the user to go across and to go down. Well, we can't really do both of those at the same time, but we can make it easier for them to go across. So what I'm going to do is I'm going to highlight the first 2 rows, okay, including the dollar amount sold. And then over here where you see the paint bucket, I'm going to click the drop-down menu. I'm just going to select the second gray. And then I'm going to have 2 cells, or 2 rows, that will stay white. And then I'm going to do the same thing with the second. I'll click the drop-down. Actually, I don't need to. I can just click on the paint bucket. And then I'm going to highlight the next row and the paint bucket. Now, here's the deal. I'm going to highlight the next 2. I'm not going to go up and click the paint bucket. What I'm going to do is I'm going to type Control-Y. And then I'm going to highlight the next 2 rows where I would need to do this. I'm going to type Control-Y. Control-Y is a command that works in Microsoft Word, Excel, PowerPoint, all of the Microsoft Office applications. It repeats the last formatting command. So in this case, the last formatting command was changing the colors. So there we go. Now we have a table that the user can follow. And if we were to come up and sort of say we wanted to print this, and we would want to sort of say our orientation is going to be landscape, we can get almost the whole table. Let's say print active sheets, collated letter, margin, scaling. Let's come back, print active sheets, print entire, print selection. We want to go print selection. So let's highlight the whole thing. Okay. And then I'm going to come back up to print, and I would say print selection. So now it shows me my entire thing, or my entire, sorry. No, it doesn't. It still doesn't. That's crazy. Okay. But I'm just showing you that in the print, now we have all of the cells broken up, and now you can follow yourself left to right by following those gray lines that we put in. Oh, we didn't select anything, so that's why. There we go. File, print, and we're still on print selection. So now you can follow yourself left to right. So now the only way that you might get lost is if you're going down a different column, but you can just sort of say, okay, at 400 bolts, I can work my way down, and based on where I am in the gray and white rows, I can find out what the price per bolt was and how much I'm going to make. So this is an example of relative addressing. Of mixed addressing. So we've gone through relative addressing, fixed addressing, and mixed addressing. Now I'm going to save this, okay? Now I'm on a different computer because I'm at home, but I'm just going to go ahead and say browse. I'm going to come to my C, my users, me. Let's go ahead and put this in MATLAB just so you'll be able to see it in the rest of ours. And I'm going to call this my Excel referencing and, ooh, no. Good. And formatting. Okay? Because now the next thing I'm going to do is I'm going to come up to File, I'm going to say New. And I'm going to open up a workbook. So the next topic that we're going to talk about is statistics in Excel. So I'm going to put that up top. Statistics in Excel. Well, let's go ahead and give ourselves a little bit of idea of, bold and bump it up, since that's our descriptor. Now here's what we're going to do. We're going to say that we have batches. We'll say batch 1. Oops. And batch 2. And batch 3. And we'll just go ahead and highlight those, and we'll click, hold, and drag over. We'll give ourselves 5 batches. Okay, we're going to say, what do I want to do? I want to do samples. So we'll say sample 1, sample 2, sample 3. Oh, that's not a 3, that's a 4. It really would have messed up my formatting. So we'll highlight those and bring them down. Let's say we have 25 samples in each one. I'm going to double click the right-hand edge of B column. That way we get it all out. I'm going to highlight all of the cells in this field. I'm going to align them center vertically and horizontally. And then I need 100 random values. Well, when we had 10 samples of masses, I went ahead and filled it all in. I don't want to do that now. So we've used a function before. I'm going to zoom in a little bit. And that function was equals rand between. Open parentheses, it tells me I need a bottom and top value. So we're manufacturing bolts, right? So let's say I want a nice spread. Let's say they're 1/4-inch bolts again. So let's say 0.24 and 0.26. All right, so we're going to do 1 hundredth above and hundredth below my nominal value. Now I have that same problem that I had before, right? So let's actually say between 24 and 26, and then we're going to divide by 100, so I get what I need. All right, so then I'm going to click, hold, and drag down for that column. Okay, this is because rand between will only generate integers. So I need 24s and 26s, and as a matter of fact, that's not really going to be good for me, so let me undo that, because what I actually need is I need between 24, and we're going to add 2 more zeros, and to our division we'll add 2 more zeros, because now I get 4 decimal places. So if you remember when we talked about the 68, 95, 99, 7 rule, we talked about taking a sample size and looking at our 68% of the bolts between this and this value, our 95% between this and this value. And that's sort of what I want to build towards, because the purpose of this is to show you how to compute summary statistics in Excel. So I need some precision. For my precision, I have to do some stupid stuff. These are fundamental limitations of Excel, so we just have to work around them. So now we have our sample down to 4 decimal places. Let's go ahead and copy that down. For my second, I'm going to have equals rand between. Okay, let's make a batch that we know is going to be bad. So let's say between, I want this one to be between 0.22 and 0.27, which means I need to be 2, and I think we did 1, 2, and 27, 1, 2, and we divided by, I think 10,000. Let's check. Yeah, that worked. All right, again, I'm going to click, hold, and drag down. So now I have a batch that might be good. I have a batch that I definitely know is bad. Let's go ahead and say for the next one, I'm going to have rand between, open parentheses. I want this one to be like 25, 1, and no, 24, 90, and 25, 10, and then we're going to divide it by, again, 10,000. And again, we'll click, hold, and drag down. And then for the last two, we'll just do the same as the first one. So I'm just going to copy, and we'll just paste that into here, and then we'll just click, hold, and drag down. So we have 3 that we know might be good. We have 1 that we know is bad, 1 that should definitely be good. So now I have my random values for computing my summary statistics. Let's go ahead and sort of do this. Let's give it borders, right? Okay. Underneath this, I'm actually going to merge these and leave a blank line. The next thing is I want the mean, then I want the variance. Actually, let's do the median, the mode, the variance, the standard deviation. Let's do the min, the max, and the range. Okay. Now I have a problem here with standard deviation. Standard deviation is 2 words. Those 2 words far exceed the length of anything else in this column. So what we're going to do is we're going to make line 34 twice as tall, or at least about twice as tall. It does not have to be exact. I am going to select that cell, and up here right above merge and center, there's something that says wrap text. So I'm going to select wrap text. And now Excel has wrapped the text to the next line, so it all appears to be in the same cell. We didn't center justify any of this, so let's go ahead and do that. Let's add borders to it. We'll center align, center align. Come on. There we go. Now we're all center aligned. So now I have all of my data that I'm going to need, and I can begin computing all the summary statistics. Well, for the mean, we're going to type equals average, open parentheses. Now for batch 1, I'm simply going to hold my mouse and select all of my data. So click, hold, and drag and select all of the data. Close parentheses and press enter. For my median, I'm going to type equals median, open parentheses, select all of my data, press enter, equals mode, open parentheses, select all of my data, equals VAR, open parentheses, select all of my data. For my standard deviation, it's equals STDEV, open parentheses, select all of my data. For my min, equals min, open parentheses, select all of my data. For my max, equals max, open parentheses, select all of my data. And for the range, I just say equals max minus min. There we go. Now, to get the values for the rest of it, we have to do several things. So first, we designed this experiment so that, or example, such that we understood we were going to be measuring all of these values down to 4 decimal places. So that means that all of my summary statistics likewise need to be down to 4 decimal places. So I'm going to highlight, not like that. I'm going to highlight all of my data. I'm going to turn those into numbers, and I'm going to increase the number of decimal places to 4 decimals by clicking this little button here. See, I can increase the number of decimals, decrease the number of decimals, but I'd like 4. Then I'm going to highlight all of my computed summary statistics. I'm going to turn those into numbers, and similarly, 1, 2. Now I have 4 decimal places. And the next thing I'm going to do is I'm going to highlight all of my summary statistic calculations for batch 1. And you'll notice that again, there's the little square at the bottom right-hand corner. I'm going to click, hold, and drag over. And now I have my summary statistics for all of them. And this one is pretty small. I'm sorry, this one doesn't exist because there isn't a most likely occurring value because they're all unique. In the others, we had such a close, such a small standard deviation. So you remember our first one, we didn't know if it would be good. Our second one we knew would be bad. Our third one we knew would be good. And our last 2, we weren't sure that they would be good. But the second one, we knew it was going to be bad. We gave it a pretty big standard deviation, right? You can see that here. Here I have a standard deviation of 0.0057. Here I have a very small standard deviation, 0.0006. This is like unreal. And then here, 0.006, 0.005. But this one's 0.01. So that means I have a lot of spread in my data. That's not good, right? My manufacturing process is not reliably repeatable. Therefore, this machine, if all of these bolts came off of one machine, if this was a production line and I had 5 machines running, this machine needs to be taken offline for maintenance right now because it is just taking my raw materials and creating nothing of use. So we got to take that one offline. But the rest of them, because we had a smaller standard deviation, we have values that do repeat. Like if I come over here and I just start changing my spreadsheet, see now this one doesn't have a value that repeats. Let's just change a few more things. And every once in a while, you'll see that some of them don't have values that repeat. Well, let me highlight all that, clear contents. So what's happening now is, and I guess I should state this first, this is how we compute the mean, median, mode, variance, standard deviation, min, max, and the range for data in Excel. Okay, again, we could just sort of highlight this, make it bold, highlight all of this, make it bold, and highlight this and make it bold. We could give our B column a little bit more width, and there we go. Okay, so now we have all of the data, and we have all of the summary statistics to, again, the point of summary statistics, right, is to take a vast amount of data, and I know this is only 25 points, but it's not easy to look at 25 numbers and go, yeah, okay, that looks good. But we take those 25 values, we compute a set of numbers that sort of tell us a story about those 25 numbers. So these numbers tell us some things about this set. So, but right now, this is fine. Okay, we're going to save this. And again, we're going to be in our MATLAB folder, right? And I'm going to call this summary statistics using Excel. All right, so now I'm saved. And now I'm going to go ahead and I'm going to, actually, before I do that, I'm going to copy my data, okay? We're going to do the same thing we did the last time we used ran between. I'm going to copy it. Then I'm going to right click. I'm going to come down to paste special. I'm going to do it this way just so that we can do you can see the pop-up. Select values, select OK. Now this is being recorded, so you can back that up. I'm not going to do it again. But you could have just said a right click and then selected this icon. Same thing. Now when I change things in the spreadsheet, nothing changes, right? So that's ideal. Let's clear those contents. I'm going to save this because what I want to do now is I'm going to copy all of that data, my 100 random numbers. And by the way, my 100 random numbers are going to be different from yours. So I'm going to copy my random numbers. I'm going to come to File, New, Blank Workbook, and starting in cell A1, I'm just going to paste them. And with that, I'm going to come to File, Save As, again in my MATLAB folder. We're going to say Batch Data from Excel. Okay, so now I have my batch data, columns 1 through 5, 25 values, excuse me, in Excel. I'm going to close out Excel. It's all gone. I'm going to open up MATLAB, see where we are. We're at how many minutes? 45 minutes. Wow. We're going to get through a 2-hour lecture in like a little while. All right, so And this is my personal computer, so you've got my projects and then all of our data stuff. So I'll have to change this later, but what I'm going to do is I'm going to start a new script, right? It's what we've done all the time. So with my new script, I'm going to type clear CLC. I need to come over here, preferences, fonts, and let's not do 10. Let's do, that's too big. Let's do 14. There we go, 14. So now you'll be able to see everything. So clear in CLC. Well, we've already tackled at this point in the semester how to bring data in from Excel. We use a function called XLSRead. Okay, now XLSRead is a function, so it has to be open close parentheses, right? And inside of that, we have to give it the name of what we want to bring in. That name is going to be over here. That's batch data from Excel. So I'm going to select that, right click, rename. I need the file extension as well, so I'm just going to select the whole thing. Right click, copy. Then I'm going to come back to my script. It's really just the easiest way. And I'm going to say paste. But because this is a string, and everything that we reference as a string in MATLAB has to have apostrophes around it, I'm going to have apostrophe, my file name, apostrophe, and then that's it. Okay, so there's my string. Now I need to save that as something, so let's go ahead and call it data. So now I have data being read in XLSRead. Now, I'm going to show you how to do a few things, and then I'm going to show you something weird about XLSRead. It changed about 3 years ago, and this is 2019, so about 2016. And I don't know why it changed, but it just is what it is. So that's this. Let's go ahead and let's put down everything that we want to compute. I want the mean of each column. Okay. Then I want the mean of each row. Then I want the mean of the entire array. Okay. Then I'm going to copy this because I'm going to go paste because now I want the mode. And then I'm going to paste. Oops. Too many copies at one time. I'm going to copy all my mean stuff because median is really mean with, you know, a DI in the middle. So I'm going to type, I need the median of each column, median of each row, median of the entire array. Then I want the, we'll do variance and standard deviation next. So let's go ahead and do copy paste. And we'll say I want the variance of each row and the variance of the entire array. And then I want the standard deviation. And that is not, it's a mechanical keyboard. It's very hard to type on it. It's not meant for this. It's meant for something else. All right, standard deviation. Then I need the min and the max. So we'll do min. Highlight all those. Come down, and we'll also do max. All right. There we go. Now, in past examples, what I've done here is below each one of these comments, I've typed the code that we need to accomplish the task. We're actually going to do that to the left because this will get pretty hairy if we double the number of lines. I'll have to go up and down for the sake of example. So what I'm actually going to do is I'm going to say col underscore means equals, okay, I'm going to use the mean function, so I'll have to have open close. I'm going to give myself some spaces out there just to put my comment out there a little bit to the right, so it makes it a little bit easier to discern what the function is and what the comment is. Now I'm going to take the mean of something in the data array, but I don't really know what that is. Like I'm going to use the mean function, right? But I have 25 rows and 5 columns. So now I'm going to press save. I'm going to call this, I guess, stats underscore in underscore MATLAB. Okay, because I did this for class. I'm going to trash this. I'm going to be honest. I'm going to trash this file when I'm done. It's going to be identical to what we did before. But, okay, so this is what I'm going to run. I'm going to run it for 2 reasons. I'm going to leave it unsuppressed. The first reason is to show you the oddities of XLSRead, or the oddity. The second is to show you what comes out of using this mean function when I give it a 25 row by 5 column array. So I'm going to run it. And I'm waiting. And by the way, I'm running this on a pretty powerful computer. So I'm waiting. There, now we're done. Now I want to show you this, okay? Because we'll talk about what came out in a minute. Now I'm going to run it again. It's done. That's the oddity of using XLSRead. I have absolutely no idea what the hell is going on. But something changed 3 years ago, and the first time you use XLSRead, it's going to take a long time. The second time, the third time, the fourth, fifth, sixth, seventh, eighth, it is instantaneous. It's not because it's saving the outcomes. and it's just giving you the outcomes again. I really have no idea what's going on. So the first time you run this, just be a little patient, okay? You're going to press XLS read. And like I said, this is a very powerful computer. So if you are on something that is less powerful, it may take a little bit longer. Now let's talk about what came out. So I had 5 columns, right? Now I have 5 values. 1, 2, 3, 4, 5. We can summary statistics using Excel. Let's go ahead and open outside MATLAB just so we have it to reference. I know I told you to close it. In the first one, my mean was 0.2519. Here I have 0.2519. So what this is this is the mean of each column, which is why I call it column means. But that's not sufficient for me because one of the reasons I don't like people using Excel is that when I'm using Excel, I'm using somebody else's black box, okay? And a black box is it's like Schrodinger's cat, okay? It's a box that you can't see inside. You don't know what's happening. And if you don't know what's happening inside, then you can't make any statements or declarations about what is happening at all. And therefore, one of the reasons that I dislike Excel for engineering calculations is that if you use an Excel spreadsheet that somebody else wrote, then you don't know if it's correct because it may target the wrong information in a calculation or an equation cell. So that's one of my big reasons for not trusting things done in Excel. But that's my thing, not yours. It's based on experience that I have that you don't. So then again, I'm cynical and jaded, so not sadistic. Although you might think so on the test. So now I need to know a little bit more about the mean function because I'm using somebody else's black box. But here I can get some help, right? I can type help space mean. Any function I use in MATLAB, I can type help space and then the function name. This is what we did, mean of x. Our x is data, right? This is the name of the generic array that they're pretending we're going to compute the mean of. Here I have the mean of x, comma, and then the word all. That seems like it's going to be pretty useful later since we need the mean of everything. But here we have the mean of x, comma, dim. Okay, now you can read this at your own discretion. You can type this into your command window and continue to read it. I'm going to come back. We're going to just type comma 1. That's going to be my first dimension. You'll notice when I run this that what I get is the same exact thing that came out before. Now dimensions are funny, okay, because I just computed the mean of each column. But you'll remember back when we talked about the dimensions of matrices, we had rows by columns, right? And then we would have rows by columns by, I call them stacks. Some people call them pages. But rows by columns by stacks. And that's if you had a cube, right? You have a cube that has, imagine taking a two-dimensional spreadsheet and then just making it taller. Same number of rows, same number of columns, but just stacking them on top of one another. Well, here I have given MATLAB 1 as the dim, as it called it as MATLAB's help information referred to it. But what did I get back? I got a row. So the way you need to think about this is this. I want the mean of data, and I want you to give me a row. What that row contains is the mean of each column, but you're going to give me a row. So mean of data, comma, give me a row. Well, I can highlight that information, copy it, paste it, and now I know this doesn't really mean anything for our batches example, but we're going to change the 1 to a 2, and this won't be column, this will be row. And I'm going to run it. And now I have the mean of all of the columns, and then I have the mean of all of the rows. Okay, so what changed there was this dim value. So for dim, if I type 1, MATLAB's going to give me a row. If I type 2, MATLAB's going to give me a column. What you have to know past that is it's going to give you a row that contains the column means. It's going to give you a column that contains the row means. So think about this 1 and this 2 as the dimensions for a matrix. The first dimension is a row, the second dimension is a column. Now, I'm going to be completely honest with you. Even though I explained that, that is confusing for a lot of people, and I understand that. So you might want to do a few examples with this where you compute some two-dimensional arrays, throw them into MATLAB, do some means of data, comma 1 and data, comma 2, just to convince yourself. Because I can explain it, but until you've done it to the point where you can predict what's going to happen before you press enter and run the command, then you're not ready to say that you know what's going on. So you need to convince yourself. The last is all, comma mean, and that's just the mean of data, comma, and then all. Okay? Now I'm going to run it. And I have the row that MATLAB gives me that contains the mean of each column, the column that MATLAB gives me that contains the mean of each row, And now I have the 1 value that's the mean of all of them. Well, let's check and verify this row 1, 0.2518. We'll come back to our spreadsheet. We'll say equals average. And there we go. So 0.2518. That's the same. And then let's say I wanted all of them. So equals average, open parentheses, highlight all of the data, press enter, 0.2494, which is exactly what I have. 0.2518 for the mean of the first row, 0.2494 for the mean of all of the data. So I'm going to suppress all of this because otherwise my command window is going to get a little messy. I'm going to highlight my column means. I'm going to paste that before modes because this won't be column means. This will be column modes, which means I need the mode function. It's as simple as that. Mean, median, mode all work the exact same way. So let's go ahead and fill all this in. I'm going to take my row means. I'm going to highlight, copy, right-click, paste. And this is not going to be row means. It will be row modes. And I will not use the mean function. We will use the mode function. And then all mean, I'm going to right-click, copy, paste that down below. And we have all mode and the mode. Pretty nice, huh? You need to do the same thing for median, so here we go. Copy, paste, copy. Let's just do this so we can change them all at the same time. Paste, oops, I'm just gonna Control V. I do the right-click copy for you guys, but normally I just Control C, Control V. So here, I need the median, and literally just gonna copy that, paste, paste, and all median, all medians, and all medians. There we go. So I have the column medians, the row medians, all median, using the median function. Column modes, row modes, all modes, using the mode function. Verify. Good. 1, 2, all, 1, 2, all. We're good. Now we have to talk about the difference. And when I run all of this, by the way, I just run it. It's all going to be in my workspace. Okay, I don't have it in my command window because I've suppressed all of these outputs using this semicolon all the way down, which is fine with me because now we're getting to the point where we're calculating numbers. We don't need to really see them to know that we've calculated them. We know that they're over here. If I wanted to see one, I could double click and my variable editor would pop up. I could double click on as much as I want. So my alls, my columns, right? So I can see all my column medians, my column means, my column modes. So I can see whatever I need. Or I just close out the variable editor. I get my complete command window back. All right, now let's talk about variance. So let's start with this, okay? We'll say column variances equals, and the function is var of data, comma 1. Well, this is a problem. And it's a problem for the following reason. Let's just jump straight into the help file. Help, comma, variance. Now, this is a little difficult to understand, so let me just walk you through it. It says y equals the variance of x, returns the variance of values in x. And here's where we go. It's a row vector containing the variance of each column. And for a two-dimensional array, like ND, right? So n-dimensional array, variance operates along the first non-singleton. That doesn't really make any sense. It just means that it's going to give you a row with the variance of each column. And then it says this, variance normalizes y with n minus 1. If you remember back to when we did our summary statistics by hand, we had that the variance equaled, and I don't have my work computer with me, so I can't show you the notes that we did. The variance calculation was, I was going to take each data point, subtract the mean, square that value, sum all of them up, and divide by n minus 1. That's because for a sample, you divide by n minus 1. For a population, you divide by n. So if I have, it says that by default, it divides by n minus 1. It's called a normalization scheme. But it can also normalize by n. And that's where we get into here, okay? Y equals the variance of x, comma 1, which is exactly what I have in this code right here, right? Data, comma 1, where what they're calling x, we call data, comma 1. normalizes n and produces the second moment of the sample about its mean. Variance of x comma 0 is the same as variance of x. Now, the reason I'm reading this one to you is I've programmed in MATLAB for a really long time, and that's confusing to me. What it means is this, that if I put a 1, I'm normalizing by n. If I put a 0, I'm normalizing by n minus 1. Well, I need this to be n minus 1, so I know that this needs to be a 0, okay? My second value needs to be a 0. Now we can look down and we can say, look, down here somewhere I say x comma w, which is that, x comma w, again, 0 for n minus 1, 1 for n, which makes no sense, but fine, and then comma dimension, which follows the same scheme as what we had done before. Now, this is how to properly compute the variance of each column. And remember, okay, give me a row. The row is going to contain the variance of each column. This is how you do it. I've made the comment before in class that when we use a function, and the VAR is the variance function, that we can pass a function, this is the information we're passing, we can pass the function multiple pieces of information. First, comma, second, comma, third pieces of information. But we have to do it in a way that MATLAB accepts, because this is their black box, so we have to feed it the data, feed it the first, I don't know, descriptor, feed it the second descriptor. These are actually like logical values to get what it is that we need. So now I can right-click, copy, right-click, paste, and I can say that the row variances are the variance of data, comma 0, comma 2. And that all variance, and not plural, is the variance of data, comma 0, comma, again, all. I'll tell you, this all got added in 2018, and man, this thing is just really helpful. It used to be a completely different process. So in the same, this is called syntax. Okay, the syntax structure for the variance function works differently from the syntax structure of the median, mode, and mean functions. But the syntax structure of the standard deviation function works the exact same as the variance function. So I'm going to say this is actually, we'll call it standard devs. STDEVS, and the function is just STD, so chuckle all you want, that's just what it is. So now I use the STD function instead of the VAR function. So I'm gonna copy that, copy, paste, and so we have rows and all, and the all is not plural, but then we said for the rows, we use a 2. For all, we use the word all. And there we go. Now, the last summary statistic that we need to work with, and how long are we? Ooh, we're getting up there. The last summary statistic we're going to work with is min. So let's say column underscore mins equals, it's the min function, it's data, and then I need to talk about what happens next. So over here, let's type CLC, right? And we'll type help space min. So for the min function, we have a bit of an oddity. Min is in the statistics toolbox, so it falls under the statistics domain in MATLAB, but it doesn't work. Again, the syntax is different. You'll see min of x comma y, min of x comma brackets, comma all, and then dim. So this is where we're going to live. But here's why. Okay, so let's type CLC. Remember, we talked about when we did logic relating to arrays. So let's say like 2, 4, 10, 20. There's A. B equals, let's say, 20, 40, 1, 2. And there's B. We said if A less than B, then we could get the places where values in A were less than B. We said B less than A, we would get the places where values in B were less than A. And we said that in order to get the information back, we'd have to say A dot times, open parentheses, A less than B, close parentheses, and we get the actual values in A that are less than B. Well, I don't know what happened, but somebody at MathWorks went, hey, you know what? It would be really great if we could just find all the minimum values and store all of those. For that, their idea was min A comma B. And with that, I get the 4 values that are the lower, or that are the lesser of the comparison from those 2 arrays at each location. So A has 2 and then 4, while B has 20 and then 40. And that's why we have 2 and then 4. And then B has 1 and then 2, while A has 10 and then 20. So that's why we get 1 and 2. So if we were to put min of data, comma 1, Good. I still have data loaded in my workspace. I'm going to type min data, comma 1. I'm going to get all ones. That's really weird. Oh, no, I'm not, because they're all less than 1. So let's type min of data, comma 0.1. Now I get all 0.1s. That's because MATLAB is comparing all the values in data, which you can see right here, to 0.1, and 0.1 is less than, it's the minimum, so then I get an entire array the size of data with 0.1s. I'm going to be completely honest with you. There are not a lot of reasons in programming to do anything like this. This is functionally like almost worthless. Okay, there are exceptions where this would be useful, but they're very few and far between. So what we have to do is understand the syntax of the min function. So again, I'm going to type help space min. So what we need to do is we need to tell MATLAB that, look, I want the min of the values in my data array compared against nothing. That's what this means. We're comparing it against nothing, and then give it the dimension, following the same syntactical dimensions that we used before. So min, comma, open close bracket, comma, 1. And now if I run this, I get the minimum of each column. So again, let's copy, paste, paste, is then I need my row, mins, and then I need all min. So this changes from a 1 to a 2, this changes from a 1 to the word all, and we're home free. Now, following suit, max works the same way, so let's go ahead and say max, max, copy, max, and we'll say, instead of mins, maxes, from mins to maxes, and from min to max. And instead of the min function, we're going to use max, and because I just don't want to write it all the time, I'm just going to copy and paste, and that's it. Those are my summary statistics. I have reading in my data using XLS read. I have the mean, mode, median functions. I have variance and standard deviation, which follow a different syntax than the first m's, then min and max. So this is everything that we covered yesterday in lecture. The homework assignment associated with this was I want you to output some information where you're going to read in the batch data from Excel, okay? And at this point, it does not matter if you use the, what was I saying? The batch data, or if you use the class data from the original lecture. All that matters, or the difference between the two, is the batch data had 5 columns, the class data had 3. Per the homework, I would just like you to build the display functions for 3, okay? So here's the deal. If you follow the example in class, if the mic worked, then you're going to compute, or you're going to write code for 3 display functions. If you follow the example here, then after you compute what it is that you need, you're going to write 3 display functions. If you write 5, I don't care, you did extra work. You only need the first 3, batch 1, batch 2, and batch 3. That's it. So again, I apologize for the mic dropping out. I hope that this helps. This will be obviously posted to YouTube. So take a look at the other YouTube videos. They're going to help you out just as much as this one will. And best of luck.